Hi guys, we're going to do the check your understanding on page 717. Okay, this has to do with the chi-square test for independence. Okay, I'm not reading this whole big 3 paragraphs thing, you can read it. But what it's trying to say is there a relationship, okay, does the data provide convincing evidence at the 1% alpha level of an association or a relationship between an exclusive territory clause and business survival for a new franchise firm? Okay, so let's first of all, franchises are... McDonald's are franchises, Subways are franchises where you buy you start a business, but it's already an established business, so you just kind of pay the franchise fee, and you have to follow a lot of the rules from corporate, but you own the individual company. Okay, you own the individual franchise. Okay, some franchises have something called an exclusive territory clause, which basically says that, like, if you buy a Subway franchise, the exclusive territory clause says something like, they will not put another Subway within like 25 miles of your Subway. Okay, so that's an exclusive territory clause. So what this information is looking at is there a relationship between how successful a franchise is and whether or not it has an exclusive territory clause. So we can see, 108 of 142 firms or franchises that have an exclusive clause, 108 are successful and 34 were not. Now, success was based on whether the franchises were still open after several years, okay? So again, read through all this so you can understand what's going on. But I'm going to use a chi-square test for independence to prove if there is a relationship between these two variables, okay? And we've been looking at relationships and independence for a while. We looked at it in the first chapter with just looking at conditional distributions, okay? If they were different, they were dependent. If they were the same, they were independent. We looked at it in terms of probability, with conditional probability. Okay, if a conditional probability equaled the original probability without any regard to the condition, it was independent. Okay, so now we're going to do an ultimate way with a chi-square test. Okay, so this is the check your understanding on page 717. I have just simply rewritten the data from the table so I can write on it and do whatever. Okay, so we're going to start with our state. Now, if we reference our cheat sheet here, the ho is always that there is no association between the two variables, which means they're independent. And the ha is always that there is an association, which means they're dependent. So we just have to fill in what the variables are. So for this one, the ho will be there is no association between having an exclusive territory clause and being a successful franchise, as opposed to my alternative hypothesis, which says there is an association. I'm going to underline those. There is an association between having an exclusive territory clause and being a successful franchise. So again, if there's no association, they are independent. Okay? If there is an association, the two variables are dependent. Okay? And of course, the book says to do an alpha of 1, I believe. Yep, 1% level. So we'll do an alpha of 1. Okay, our plan. Same old, random. I think somewhere it says something here about random. There you go. Random sample of 170 new franchise firms. So stated random selection of franchises. And then our 10% independence. I'm pretty sure there's more than 170 because there are 170, so 1,700 new franchises. And of course, franchises are independent of each other. Okay, so now for our chi-square test, we need to do that large or expected counts condition. Now, the expected counts is a little different in the chi-square test as opposed to a goodness of fit, okay? I don't know what proportion is supposed to be what, okay? It's not like I'm told 50% of exclusive territories are successful, so I can just do 50% of the total. I don't know that. So what I'm going to do is I'm going to use my table to calculate. So the equation for our expected counts, I'll put this down here, our equation for expected counts, actually, no, it's on our cheat sheet. We're going to look there. Our equation for our expected counts is the row total times the column total divided by the table total, okay? So for this one, say, I'm going to have, if I wanted to know the expected count of exclusive territories and successful, so to complement that 108, I'm going to do the row total times the column total. So let me do a little thing. You got 123 times 142, all divided by the table total. Now I'm going to hit decimal here so I don't get a fraction back. And I would expect 102. 102 out of 100 to 108 doesn't seem that much off, okay? So I'm going to fill that in my expected counts table. So 102.74, okay? Let me do the rest of them. I'm going to go over here. So for the no, yes, I'm going to do, let's see, for this one, 123 times 28 divided by 170. And again, I'm going to hit decimal. So I would expect 20, so 15 and 20 don't seem too far off from each other. For the yes, no, let's see, 47 times 142 divided by 170. I would expect 39, 39, 34, they seem pretty close. And then the last one, let's see, 47 times 28 divided by 170. I would expect 7, okay? 7, 13, I don't know, sort of close, who knows? We'll let stats figure it out. Okay, so let me fill these in my table down here. So I would expect, where are we? 20.26, 39.26, and 7.74, okay? So the first thing I have to decide for my expected or large counts is, are they all greater than 5? Yes, indeed. A little close, but definitely greater than 5. So all expected counts are greater than or equal to 5, okay? And again, that equation for expected counts is right here on your cheat sheet, okay? Row total times column total divided by table total. Okay. All right, I believe our conditions are done. So now we'll do the do, okay? And remember, the chi-square statistic, the test statistic, is the sum of all the calculations of observed minus expected squared divided by expected. Now I've got four components. Kitty. Sorry, Kitty's walking on all over everything. Get back, Kitty. Okay, I've got four components. So I'm going to, Kitty, she's going to attack the book. Kitty, stop. So I have to do all my expected. So I'm going to get these up here in order. Sorry, I'm trying to let you see everything. So I have all my observed, excuse me, these are my observed. I had 108, I had 15, I had 34, and I had 13. Now I'm just going to subtract from them what I would expect, which is what I just calculated in my expected values. Watch out, Kitty. Move up. Move up, Kitty. Sorry. My cat is literally sitting at the end of the notebook, and I can't push it up. Okay, so for the 108, I would have expected 102.74. So I have to subtract that, square it, and divide it by that, okay? Same equation that we use for the goodness of fit. So for my 15, no exclusive territory, yes, success, I would have expected 20.26. So I'll square that and divide it. For my 34, yes, exclusive territory, no success, I would have expected 39. And I'll square. And then for my 13, I would have expected 7.74 for the no part of the two-way table. Okay, put all those individually in my calculator, and I get something like 0.27, 1.37, 0.70, and 3.57. Kitty, move it. Sorry, little kitty walked right in front of the iPad. Oh, there's little kitty. Kitty, you gotta scoot. You're on top of everything. Add those up, okay? So if I add those up, I will get a chi-square of 5.91, okay? Now, of course, just like the other chi-square test, I'm gonna run this one in my calculator. So I'm gonna double check my chi-square statistic, get my p-value, and note my degree of freedom. Now, first of all, degree of freedom, and again, on your cheat sheet, degree of freedom is the number of rows minus 1 times the number of columns minus 1. Now for this, watch out, Kitty. I had 2 rows and 2 columns. Don't include the totals, okay? So my degree of freedom is going to be So rows minus 1 times columns minus 1. So I had 2 rows and 2 columns. Of course, that's 1 times 1, which is 1. So I have a degree of freedom of 1. Okay, let's go ahead and put these in. Now for this one, it's a little different on how we enter it. I'm not going to have a list 1 and a list 2. I actually have to enter my table in a matrix. Okay? Sorry, I'm trying to get my calculator so it doesn't look funny. Okay, so I have to enter it into a matrix. So your matrix, a matrix is right here on your calculator. Okay, so we're going to hit second matrix, go over to edit, and this was a 2 by 2, 2 rows and 2 columns. So I'm going to enter in 108, 15, 34, and 13. Okay, so my matrix looked just like my table without the totals. So now when I go to stat tests, and again, I can go down. Oh, Kitty, sorry. She keeps knocking everything. But I'm going to actually go up because it's faster. I'm going to do my chi-square test. Oh, we forgot to write that in our plan. Let's go back and write it in our plan real fast. I forgot. Chi-square test, and this is for independence. Chi-square test, whoops, of independence. Okay. Sorry, I forgot to do that. Now when I run my chi-square test, it's going to say, are your observed values in matrix A? Yes, I just put them in. And as soon as I run it, it's actually going to dump my expected values in matrix B. Okay, I'm going to calculate. And I'm going to confirm. Let me get my, I'm going to confirm my chi-square. Yep, I got 5.91. My degree of freedom is good. And I'm going to put my p-value. Let's record our p-value, 0.015. Okay. Now I want to go back and show you, before we evaluate our p-value against alpha, let me go back into the matrices and show you the expected, because it did calculate those expected in matrix B. Okay, so when I went second matrix, I went over to edit to first create my matrix A. Well, I'm not creating right now. So if I look at matrix A, that's what I entered in for my observed values. But if I go back to matrix and I just look at matrix B, it actually entered all of my expected values. So it calculated those for me. So you can see how they match exactly what I calculated. So you can kind of just let the calculator run those. You still need to know how to calculate the expected value, because I can see you being asked a multiple choice question, okay? But you need to definitely record your expected counts on your sheet or on your test, because you can't say that they're all greater than 5 without showing that they're all greater than 5, okay? All right, let's finish this up. So we have a lovely p-value of 0.015, so we will assess it against our alpha, which was 0.01, and that indeed is not true. So we know our p-value of 0.015 is not less than alpha of 0.01, so we know we have to fail to reject the hoe. So if I fail to reject the hoe, it means I do not have convincing evidence there is an association, okay, between having an exclusive territory clause and being successful. So I do not have enough evidence that they're dependent. Therefore, I think they're independent, okay? So here's my conclusion. We do not have convincing evidence that there is an association between having an exclusive territory clause and being a successful franchise. Therefore, they are independent. Okay? So that is my chi-square test for independence in a nutshell. Okay, see you all next time.